Can you imagine all of the world's supervolcanoes erupting at once? It's the stuff of apocalyptic disaster movies. But what is a supervolcano exactly, and what would happen if they all went off simultaneously? First, let's talk about what makes a volcano super. There are no formal criteria, but generally, geologists consider a supervolcano to be one that has had an eruption with a volcanic explosivity index of 8, the highest level on the scale. VEI 8 eruptions eject more than 1,000 cubic kilometers of material. That's enough debris to fill 400,000 Empire State Buildings. For comparison, the 1980 eruption of Mount St. Helens was VEI 5, ejecting just 1.2 cubic kilometers of debris. There are about 20 supervolcanoes identified worldwide. Some of the most well-known ones are Yellowstone caldera in the western US, Lake Toba in Indonesia, and Taupo in New Zealand. The areas covered by these volcanoes are massive. Yellowstone caldera is a staggering 55 kilometers by 75 kilometers. That's bigger than Rhode Island. What makes supervolcanoes so dangerous isn't just their size, but the mechanism that triggers the biggest eruptions. Unlike a regular volcano, supervolcano eruptions come from reservoirs of molten rock, or magma chambers, deep underground. Over tens of thousands of years, these chambers fill with gas and pressure builds up, resulting in a massive explosion when the magma finally reaches the surface. The trigger for a super eruption is still being studied, but likely involves injections of magma into the chamber that destabilized the system. At Yellowstone, earthquakes and changes to the landscape have been recorded before previous eruptions. Right now, the ground is rising by about 10 inches per year, indicating the magma chamber is filling. The last super eruption from Yellowstone was over 630,000 years ago. On average, they seem to happen about every 600,000 to 700,000 years, which means we could be due for another one soon on geologic timescales. However, many scientists think we probably have another 100,000 to 200,000 years before that happens. Let's hope they are right, and it remains dormant if all supervolcanoes worldwide were to blow their tops at once. To understand the true power of supervolcanoes, let's look at some of the previous VEI 8 eruptions that have occurred and their devastating aftereffects. The oldest identified super eruption took place 2.1 million years ago in Ukraine, with the massive eruption that formed the Pervomaysk caldera. This eruption ejected a staggering 2,500 cubic kilometers of debris, enough to blanket the entire state of Texas in over 15 feet of volcanic ash and rock. Around 74,000 years ago, Mount Toba in Indonesia exploded in the largest volcanic eruption in the last 25 million years. It ejected 2,800 cubic kilometers of ash, sulfur dioxide, and other gases into the atmosphere. The gases reflected sunlight and cooled the planet for the next decade. Genetic studies suggest that the eruption nearly drove humanity to extinction. The global human population may have dropped to just 10,000 people, our lowest numbers ever. The Taupo volcano in New Zealand has been active for at least 300,000 years, with major super eruptions every 1,000 to 5,000 years. The Oruwanwi eruption, 26,500 years ago, was the largest, with 1,170 cubic kilometers of material released. That's enough to bury the entire Los Angeles metropolitan area under 3.7 meters of debris. The eruption column reached stratospheric heights and caused a decades-long volcanic winter that drove many species in New Zealand to extinction. As you can see, supervolcanoes have had devastating consequences even when just one erupts. The gases, ash, and debris they spew into the atmosphere can dramatically affect global climate and weather patterns for years. Electrical grids, communications networks, transportation systems, and any infrastructure for hundreds or even thousands of kilometers around them could be crippled. Now imagine the impact if Yellowstone, Taupo, Toba, and 15 other supervolcanoes erupted simultaneously around the world. It would truly be an extinction-level event. Let's hope the geologists are right that the chances are low in our lifetimes. Now that we've covered what supervolcanoes are capable of, let's explore what would happen if they all erupted at the same time. First, we'd see immediate effects of the simultaneous explosive eruptions. We're talking about fiery blasts with the energy equivalents of multiple nuclear weapons going off at once. Each supervolcano would spew billions of tons of molten rock, toxic gases, and debris into the atmosphere at over 1,000 kilometers per hour. Massive pyroclastic flows would race down the slopes at speeds over 700 kilometers per hour, incinerating everything in their path with temperatures exceeding 1,000 degrees Celsius. These would extend for hundreds of kilometers past the caldera rim. Imagine hellish scenes as Yellowstone, Taupo, and Toba all generate apocalyptic fire clouds at once. We'd also see massive earthquakes and tsunamis generated as the supervolcanoes empty their magma chambers in violent explosions. Coastal areas near eruption zones would be battered by walls of water reaching 50 meters or higher from the earthquakes and underwater landslides triggered. Cities like Auckland, New Zealand, near Taupo volcano would be devastated. Within hours, ash fallout would begin blanketing areas near the erupting supervolcanoes. We're talking over 10 meters of heavy, dense ash accumulating around sites like Yellowstone and Toba. Ash particles are like coarse sandpaper. This much debris would collapse roofs and buildings, shred lungs, and clog machinery. Even a few centimeters bring modern infrastructure grinding to a halt. Air travel would be grounded across the globe. Now imagine this hellish ash cloud expanding to cover whole continents. When Tambora erupted in 1815, ash fell as far as 1,300 kilometers away. With over a dozen supervolcanoes erupting, nowhere would be safe. Within weeks, dense ash clouds would circle the entire planet. With so much ash and gas spewed into the atmosphere, sunlight would be completely blocked, leading to a years-long volcanic winter. Temperatures would plummet 15 degrees Celsius or more across the globe. Freezing conditions and frost would threaten agriculture worldwide, even in the tropics. Acid rain would follow, as all the sulfur dioxide and gases released by the supervolcanoes mixes with water in the atmosphere and falls as corrosive rain. Rivers and lakes would be dangerously acidic, killing fish and aquatic ecosystems. With drinking water contaminated, obtaining clean water could become almost impossible in the aftermath. The combination of ash and acid rain may create a nuclear winter scenario, blotting out the sun for over a decade. Photosynthesis would grind to a halt, threatening the entire food chain from plants on up. Famine would likely set in, possibly threatening the extinction of humans as a species. So, in this regard, the simultaneous eruption of the world's supervolcanoes would unleash catastrophic events globally within hours, and lingering devastation lasting years or decades after. The climate shift and environmental impacts would threaten the collapse of civilization itself. Let's hope the geologists are right, that the chances are extremely low, and that we find ways to detect the early warning signs if a super eruption ever becomes imminent at one or more of these volcanic hotspots. In the years following the initial cataclysmic eruptions, the knock-on effects of the ash cloud and volcanic winter would start to wreak havoc globally. Crop failures would occur worldwide as photosynthesis shuts down from the lack of sunlight. Even cold weather crops like wheat and rye would struggle to grow with temperatures 5 degrees Celsius or more below normal. Widespread famine is likely to set in, as food reserves and supply chains completely break down. Mass starvation could lead to societal unrest, war, and conflicts over the dwindling viable farmland and food sources. Governments would struggle to maintain order, with global transportation paralyzed and vital infrastructure destroyed. The combined death toll from the various eruptions, ash, weather shifts, and resulting famine would likely be in the billions within several years. Ecosystems would collapse, with mass extinctions rippling through habitats already struggling to cope with the changes. Marine food chains could come to a halt, with phytoplankton unable to photosynthesize under ash-choked waters. Many species from coral reef ecosystems to tropical rainforests would likely be wiped out entirely. The icing on the cake would be when the sulfuric acid rain starts to fall, as the stratospheric sulfur dioxide and ash particles mix with water in the atmosphere. The toxic rain would acidify lakes, streams, and aquifers, posing additional threats to freshwater ecosystems. With clean drinking water impossible to find, cholera and diseases could run rampant. Safe zones with the highest chance of survival may be small volcanic islands located far from any supervolcanoes. places like the Galapagos, Hawaii, or the remote islands of the South Pacific could see the least ash fallout and acid rain. Tropical islands could also sustain some plant growth, providing sustenance for survivors. However, even these refuge habitats could eventually suffer from global climate changes. To put this all in perspective, the last time a similar mass extinction event happened was the Permian Triassic extinction event 250 million years ago, when over 90% of species on Earth died out over just 60,000 years. That event is thought to have been caused by massive volcanic eruptions in Russia. By comparison, a worldwide supervolcano eruption could catalyze mass extinctions and climate shifts even more quickly. In summary, the after effects of our hypothetical global supervolcanic eruption could threaten most life on Earth through interconnected environmental impacts, ecosystem collapses, and loss of agriculture. It illustrates the immense influence volcanoes have had on our planet's past and future. While the odds of this scenario playing out exactly are extremely slim, even one erupting supervolcano could devastate global civilization. It highlights the need to improve detection of early warning signs of an impending eruption through close monitoring. While this scenario of a worldwide supervolcanic eruption is highly unlikely, it does underscore the very real threat that volcanic activity poses to modern civilization. Although the chances are low, we do know super eruptions will occur somewhere on Earth again in the future. Even a single event could create severe global impacts to climate and flood production if we are unprepared. Fortunately, scientists are getting better at detecting early signs of pending eruptions through improvements in monitoring technology and global observation networks. For example, the rapid ground inflation at Yellowstone is continuously measured using GPS stations throughout the park. So, while we may not be able to prevent super eruptions, advanced forecasting could at least allow time to implement mitigation strategies and societal preparations. We also need to reduce vulnerabilities and build resilience to potential disruptions in agriculture, supply chains, and critical infrastructure that would amplify the crisis. Investing in effective emergency response plans and cooperation between nations can help ensure we get through even the worst-case scenarios. While we can't completely dismiss the threat, by working together proactively as an international community, we can avoid falling victim to even unlikely global catastrophes. Continuing research and sharing knowledge globally gives us the best chance of being prepared well in advance.